All right, hi everybody. It's Mr. Gerhard. We're going to go over the review assignment that I gave you in class. Hopefully some of you check it out. If not, great. If you do, fantastic. So let's just go through a couple of these problems. The first one that we're going to do is this: sketch the graph and state the domain, range, and asymptote. And the graph that we have is f of x equals 2 to the x minus 3. And real quickly, before we get into that, I'm going to do g of x equals 2 to the x, because this is actually a transformation of this graph. This graph, because x is replaced with x minus 3, is actually going to move this graph to the right 3 units. Well, 2 to the x is a graph that you should know. 0, 1 is on that graph, 1, 2, 2, 4, 3, 8, 4, 16, and 532. Those are all points that are on the graph. We also get negative 1, 1/2, because the scale is kind of tough, negative 2, 1/4, and so on and so forth. So this graph here, we'll try and draw it as best we can. A lot of concentration needed for that. It goes up and it levels out right here. That's kind of a bad part there, because there's a vertical or a horizontal asymptote, I should say, right here as we go along this line at y equals 0. Okay, now that's the 2 to the x. For the other one, that's 2 to the x minus 3, we shift all of these points over 3 units. So this point was 1, 0, or 0, 1. It's now going to become 3, 0, or 3, 1, I should say. This point was 1, 2. Now it's going to become 4, 2. This point was 2, 4. Now it's going to become 5, 4. And so you can see this graph is being just shifted over to the left. Instead of 3, 8, it's going to be 6, 8. Instead of 4, 16, it's going to be 7, 16. And then up here is 8, 32. And again, the asymptote stays the same, but that graph, getting a little bit better there, is going to go up like that. Now, when we look at this, the domain for all exponential functions is negative infinity to infinity. All right, because negative infinity to infinity is all real numbers. This goes to the left and to the right forever. The range, however, is going to be 0 to infinity. And that's because we're never going to go below that asymptote, which in this case is y equals 0. So exponential functions look similar to this. It's going to all be a transformation off of something that's similar to this. So we need to just work with those values. Now as I roll down here to the logarithm graph, again, if I look at log base 2 of x, let's just say that's f of x, log base 2 of x, sorry for the sloppy handwriting, log base 2 of x is going to be the inverse of the base of 2 to the x. So there's 1, 0, there's 2, 1, 4, 2, 8, 3, and then you have like 1/2, negative 1, 1/4, negative 2, and so on and so forth. And this one, these logarithm graphs, have a vertical asymptote. So our vertical asymptote here is x equals 0. And it keeps going down forever. Now when I look at this right here, I realize that that is now not the same graph. This is a reflection, and because it's inside, it reflects across the y-axis. And so now my points are going to be here at negative 1, 0, negative 2, 1, negative 4, 2, and negative 8, 3. Also negative 1/2, negative 1, negative 1/4, negative 2, and that graph is going to look something like that. Again, the asymptote is still x equals 0. The range is all real numbers now because it goes down forever and goes up forever. And our domain is going to be sitting here looking from negative infinity to 0. All right? And so that's how we go about that problem. Moving on to the back, I asked you in your handout to change this to 6%, so we go ahead and do that. When I read this problem, if $2,000 is invested at an interest rate of 6% per year compounded monthly, find the amount of the investment at the end of 4 years, that sounds like a lot of information. So what I like to do is I like to say, all right, well, this $2,000 that's our p value, that's our principal. The rate of 6%, that means I'm going to put r equals 0.06. The fact that it's compounded monthly, there's 12 months in a year, last time I checked, so we're going to say that n is equal to 12. And at the end of 4 years, t is equal to 4, and so that's our information. Now, why do we have all that? Well, because we're compounded monthly, we're going to use this formula. A equals p times 1 plus r over n to the nt. And I just plug in what I know. 2,000 times 1 plus 0.06 divided by 12 raised to the 12 times 4. Make sure that if you have an 84, you put that exponent in parentheses, otherwise you're going to get the wrong answer. And my answer to that one, if I plug it into my calculator, is $2,540.98. All right. The other thing that I asked you to do is I said, okay, well, let's think how Mr. Gerhardt thinks. I'm asking you compounded monthly, but what if we said compounded continuously? Continuously. And if that's the case, we're going to use A equals P e to the RT. Well, again, plug in what you know. 2,000, E is the number E, to the 0.06 times 4. Plug all that information into your calculator and you get $2,542.50. And that's our answer if it's compounded continuously. So if it's not continuously, we would use this formula over here on the left. If it is compounded continuously, then we use that PERT. The question number 4 says write the equation in exponential form. Well, the basis for all exponential problems and logarithmic problems is log base b of x equals y if and only if, we use this double arrow, b to the y equals x. Alright, so here's my base, 5. I'm going to go across the equal sign, and that's my exponent, and that's going to equal what I'm taking the log of. So 5 to the 4th power equals 625. And so to write it in exponential form, say 5 to the 4th equals 625. Number 5 is asking us to put it in logarithmic form. So if I scroll up here, we still have the same idea. Here's b, identify that base. So the base is 7. The base here is going to be 7. So when I write it in logarithmic form, I'm going to write log base 7. And then this part right here is what's on the opposite side of the equal sign. So 7 to the, or log base 7 of b equals x. Thinking about it again, translating back to exponential form, 7 to the x equals b. I go across the equal sign and back, and that works out just fine. For number 6, we got to find the domain. We added a domain rule when we started talking about logarithms. That was what we're taking the log of. In this case, 8 minus 4x has to be greater than 0. It's got to be a positive number. So we're going to say 8 minus 4x is greater than 0. When I go ahead and subtract 8, I get negative 4x is greater than negative 8. When I divide both sides by negative 4, I get x is less than 2, meaning that I get negative infinity to 2 as my solutions. Now, a couple points. One, when I divide by negative 4, you got to flip this sign. Inequalities, when you multiply or divide by a negative, you got to flip the sign. Second thing, x is less than 2. Don't make it 1 then and include it. Just keep it as x is less than 2. And we're going to include all numbers all the way up to 2. That's why we use the parenthesis and not the bracket. Okay? Now, last two questions. Number 7, we got to expand. Expand, we're first going to look for division, which we were going to write out as subtraction. So I'm going to write log base b of x to the 4th minus log base b of y z to the 5th. Now this right here is multiplication, so I'm going to split that up, but I have to split it up by doing addition, and I have to make sure that it's in parentheses because we're already subtracting this log. So you can see log base b of y plus log base b of z to the 5th. I keep my log base b of x to the 4th out front. Now I'm going to distribute this negative, so it's going to become negative log base b of y and negative log base b of z. The other thing I'm going to do is I'm going to bring the exponents in the logarithms and put those out front. So 4 log base b of x minus, oh man, let me see if I can erase here. Sorry about that. Erase. There we go. Good. And so minus log base b of y minus 5 log base b of z. And that's our final answer. Whenever I have more than one thing on the bottom, they're going to have minus signs in front of them. So that's very important that we do that. Okay, so we're going to finish up this last one. Sorry about the technical glitch. I'll try and edit that out, but we'll see what happens. So the first thing that we're going to do is we're going to go ahead and we're going to look to see if there's any numbers in front of the logarithms. Here we got a 6, so we're going to bring that up. So we're going to get log of x squared plus log of x cubed y plus log of y to the 6th. And then with all this being addition, it's really going to be multiplying this x squared times the x cubed times y times the y to the 6th. We could do it one at a time, or we could do it all together. We'll go ahead and do it all together. So because it's all multiplication, we're going to have x squared, y cubed, y from there, and then y to the 6th from the last one. And the last step in this would be to go ahead and simplify all this, and we get log of x to the 5th, y to the 7th. And that would be our final answer. So in reviewing for your quiz tomorrow, make sure you review all your exponent or your law of logarithms properties. Make sure you know how to graph and find domain and range. Make sure you can find the domain of logarithm functions, evaluate logarithm functions, go from logarithmic form to exponential form, and all the PERT and investing stuff. So hopefully that helps out, and we'll see you tomorrow.